So today we will be covering the basics of electronics, a bit of programming, and a bit of hands-on exercise. So we're going to be learning about, how do we make those concepts more practical.
Yep, carry on.
And we'll be programming some electronic equipment, right? So I'll probably start with giving you guys just a very basic, and I think maybe some of you might already know all those things, right? So if I'm telling you something that I already know about, so then let me know, I'll stop there, right? And then we can move faster. So let's talk about electricity first. And it's important because we are going to be playing with some electronic equipments, and we know the very basics of how electricity actually works, right? How the lights get turned on, and and how everything works, right? So let's probably cover. So what happens is that when you connect something into a wall socket, right? So what happens is the flow. So think of electricity as water, right? So I mean, whatever flows in the wires, think of that as water, right? So this is a socket. And this is a wire, and that wire gets connected to some electric equipment, right? Okay, and then the electricity flows in this wire in the forms of something we call electricity. So they're going to be flowing in this wire, and they're reaching here. They're turning on the equipment, right? So how do we know that it flows from here till here? Why doesn't it flow from here to here, right? So the idea is that the flow of electricity, right, always moves. It's just like water. So when you connect a pipe, right, so the water will flow from a high end towards a low end, right? So think of electricity as exactly like water. So the reason why it flows from here to here, because the pressure of electricity, I'm using very simple terms, right? It's higher here and it's low here, right? So think of this bucket to be a massively big bucket of electrons, right? And this is a smaller bucket, and there's a hole here that and this is a smaller bucket, right? So the water will flow from this bigger bucket to this smaller bucket. And in electrical terms, a bigger bucket is called plus sign, and a smaller bucket, think of it as like minus sign, for example, right? So electricity always flows from the plus sign to the minus sign, right? Plus is high big bucket, and then minus sign in the small bucket. So think of this battery, right? So on this battery you'll see the plus sign, and on this side you'll see the minus sign, right? So if I plug anything here, the electricity will flow from the plus sign to the minus sign, right? I mean, you can have a look at this, right? So on the side you can see the plus sign and the minus sign, right? Okay? Can you see the plus sign and the minus signs? Yeah. So you can give it to me. Okay. So that's clear, right? Electricity flows from where to where? From the plus to the minus, right? Okay. That's good. And so the bigger the bucket, right, the higher will be the flow of water, because the pressure is big, right? If the difference between the two buckets is not that much, the flow will be less, right? Does it make sense? The bigger the bucket, the more pressure of the flow, the smaller the difference between two buckets, the smaller the flow of water, right? And that size of the bucket, how big the bucket is called V, or voltage, right? So voltage is the size of the bucket. So on the same battery that you got, right? Check how much it says 9V, right? So 9V, it's 9 volts is the size of this bucket, right? There could be other buckets, 5 volts or 3 volts, or the socket size 250 volts. I mean, they are big buckets, right? Okay. Does it make sense?
Yes.
Can you see 9 volts? Okay, so that's voltage, right? So this is so if I have 9 here and I have 0 volts here, so that means a really big bucket, right? And that's a very small or negligible bucket, right? So where will the electricity flow?
To 0.
From 9 to 0, right? Okay. So this will flow this way. Okay. Now we will cover two more concepts, right?
Just a question. Do we put this back in the box?
Yeah, just put it back in the box, yeah. Okay, so two more concepts to cover, right? And then we will, do a bit of mathematics, right? And then we'll kick off, right? So, and I'm trying to explain to you guys in a very simplistic term, right? So, if I put a ball here, right, a small ball here, what will happen to the ball? Think of this as water flowing from the pipe, right?
So it'll be pulled in with the rest of the electricity.
Right, it will be pushed out, right? And if this is not a ball, think of this as sort of like a little lump of sand, for example, right? What will happen to that? It will just dissolve and in the water and it will go away, right? Right? And if I have a bigger lump and a stronger lump, then it can stop the flow of the water, right? Okay. So so the idea is that so the idea is that, okay, the bigger the stack of sand, right? It will protect the flow of the water, right? If it's a smaller one, it will flow with the water, right? Does it make sense? So this thing in the middle that is coming in between the high volt and the low volt could be anything like a bulb, right? Or today we will look at LEDs, right? Right? So today.
Yep, carry on.
So LEDs, right? So think of this, right? So I mean, if the size of if the resistance the LED can resist of the flow of the water, right? Then LED will survive. Otherwise, the LED will just blow away, right? So I'll show you guys what the LED looks like. So that's an LED, right?
Pass it on to everyone.
So now the concept that I want you guys to understand, right, is that so we have to look at how much flow of water the LED can survive, right? If the flow is very high, the LED will be destroyed, right? If the flow of the water is slow, the LED might survive, right? If the LED is strong enough and the flow is big, right, then again LED will survive, right? So that survival of the LED depends on the resistance it has, right? Or yeah. So it depends how much resistance the LED can sort of like survive, right? So what do we do? What do we do if we have got a smaller LED here and we know that it won't survive the flow of the water? Then we put something like a brick. I can put a brick here, right? So the brick will stop the flow or lower the flow of the water, right? To protect the LED. Does it make sense? So that brick that I want to put in the flow of water to just slow the flow of the water or just to decrease the rate of the flow of the water, right? That brick is called resistance. Okay? So now we learn another concept. And resistance is pretty much like, I mean, if this is a pipe, right? So I put a brick here, and this brick will control or lower the flow of the water, right? Stop the water from flowing really fast. This brick is called resistance.
So after the break, we get the pipe should not be smaller than? The pipe should not be smaller than?
Here.
Yeah.
I mean, it doesn't matter.
Okay.
So even if the pipe is the same size, still the brick will stop.
So we only
flow.
get less water then?
Exactly, yeah.
Exactly.
So wherever the water we are passing, the water will flow,
Yeah.
but the time the water takes to flow will be increased, right?
Yep.
So if there's no break, maybe the water is flowing within 10 minutes. When we put a brick or a resistance, it might take 15 minutes, right? So it's the flow of the water. We are stopping the flow of the water.
Yeah, yes. So
All
it
the water will go.
doesn't burn out my LED.
That's exactly right, yeah. So if the flow is higher and we don't stop it, it might blow off the ball or LED, whatever we've got here, right? So this flow of water, this brick, that's another concept we need to cover. This its sign is ohm, right? This is the sign of it, right? And this is resistance. And the way so where's the LED? Have you guys put it back?
Yeah.
Okay, so I'll show you another thing. This thing
It's called resistance.
is the brick, right? In our example, so pass it on, right?
Resistance.
This is a resistor. This is the brick. Okay?
I find it.
Go.
There you go. Sure.
It's good.
So that's the brick, right? Resistance. So now we have covered two concepts, right? So okay, have a look at the brick, the resistance. Okay. So now the last concept is we talked about 9 volts going to 0 volt and then putting a brick and then it decreases the flow of the water, right? Right? So now the last idea is related to the water that flows, right? So voltage is how much the water will flow, right? Brick is the resistance, right? And the rate of the flow of water is called current, right? It's identified by ISI, right? Right? Ampere or you can say current, right? Okay? So the actual water that flows is current. How much it will flow because of the height of these 2 points is voltage. If you want to stop the flow of the water or decrease the flow of the water, that's the resistance. Does that make sense, guys? Yeah?
Yes.
So can you explain me what is the resistance?
So resistance is basically stopping the flow of electricity and like reducing it so that something else doesn't get destroyed.
Very good, yeah. So can you tell me what is voltage?
Voltage is the power basically of what something contains.
Yeah, so it's the difference, right? It's the difference between one point and another point, right? Okay, what's the current?
Current is basically the flow we go through.
Right, the flow, exactly, the rate of the flow, right? Okay, that's good. I think you guys are getting very fast, so that's good. So now we've got three things, right? Voltage, current, and resistance. Okay? How are they related to each other, right? So we'll not go into the details of the science behind that, but we'll talk about the mathematical equation. So the equation or the equation that brings these three things together is
So basically formula of the
formula, right? V equals I into R.
just multiply basically.
Into R. Okay? This is the equation, right? That brings it all together. And you'll guys see how this is very useful when you start building the electronic circuits, right? So you know, in any mathematical equation that has got three variables, right? How many do we need to know before we can find the value of the third one? Two, right?
Two.
So we need to know two of them before we can find the value of the third one, right? So I'll give you a very simple example, right? So the battery, what was the battery?
9 volts.
9 volts, right? So the battery was 9 volts, right? And the LED, I mean I don't know exactly how much, normally they are like 15 to 20 milliamps, right? Do you guys know what milli is? Milli is a
Yes.
thousandth part of the energy, right? So
Just put it this way, in the 1 meter how many millimeters?
Yes, 1000.
1,000.
So in a 1 ampere how many milliampere should be?
1,000.
1000. Yes, simple. So,
So-
in other words it's a 0.015 ampere.
correct, yes, exactly, yeah. Right?
Okay.
So milli is just a thousandth part of an ampere, right? So milli mouse,
Here's a question.
if I, yeah. What's the
No question?
Do you have a question?
We go back. He'll say it later.
Okay. And now we need to find out what is the resistance. How do you guys know how to find that out?
9 over 15.
Thank you.
Correct, yes. So 9 volts divided by 15
It's a
milliamps
simple algebra. You just
is equal to the resistance, right? Because this is not a millivolt, that's a volt. So we need to convert this milliamp into amp, right? So a simple way is, you know, put a 0 here.
just put it. It's just be in a locker. Keep it in ampere. So let's put it there 0.015
Yeah.
ampere.
So
Keep it simple.
It's you know, it's 15.0. So we take this point three decimals back, right? So 1, 2, and 3. Put a 0 here and this decimal counts here, right? That will make it 0.015.
That's become ampere now.
Right? So this is not ampere, right? Okay? So now, does someone want to do a quick calculation?
9 over 0.015.
9 divided by 0.015. That will be 600. 600 ohms. So we read that the resistance is represented in
Ohm.
ohms, right?
That's the
Okay?
scientist who invented the resistance, so we remember it.
Correct. So and this formula is actually called Ohm's law, right? Okay?
That's a big thing we learned today. So now we need to, like if you're building a circuit, that's what the idea. So if I want to know what resistance should I put it on, I know that I need a 600 ampere, 600 ohm.
Ohm, yeah.
Wow.
So we will do a practical on that, right? So, okay, does that make sense? Any questions on this?
No.
Right,
No.
so we will put that into the practical perspective, right?
Excellent.
So now, so I'll write the formula on the top, right? And then I'll tell you what are we going to do today, right? Our first experiment. So what was the formula again? V equals
I can't.
I times R. Very good. Done. Okay. So actually, this is the experiment that we just did, right? So what we will do is we have got a battery, right? The battery that you guys just saw, right? And the battery has a positive point and a negative point. You guys saw that point, right? How many volts was the battery? 9 volts. Very good. And there were two little knobs on the top, right? This knob is a positive knob, that is towards the positive side, that's negative knob, right? So electricity flows from where to where? Positive to negative, right? So what we will do, we'll connect our wire from the positive and the negative, right? Okay? So now this is an exam for you, right? A test for you guys, right? If I put the LED, so the LED you saw, so let me cover the LED a little bit more, right? So you guys covered the battery. So if you again look at the LED carefully, right?
It has a longer side.
Exactly. So LED, exactly. So LED has two sides, right? LED has a longer side and a shorter side. So what is the longer side?
Positive.
Positive. Exactly. So that's positive and that's negative, right? So positive needs to be connected with
Negative.
the positive one.
Oh my god.
Sorry.
That's okay, that's okay. So positive needs to be connected to the positive one and the negative needs to be connected to the negative wire, right? So do you guys want to have a look at the LED again to identify which is the positive and the negative sides? So the longer leg is the positive leg and the shorter leg is the negative leg, right?
Always get mixed.
I think you were.
Okay. So do you know which one is the positive leg? The longer one is the positive leg and the shorter one is the negative leg. Okay, pass it on. Okay? Okay, good, very good. Okay? So now the test for you guys is if I connect this positive to the positive here and if I connect the negative to the negative here, right? And remember this was 0.015 amps, right? What will happen? What are we missing? The resistance. If there is not going to be any resistance and we'll connect this together, what will happen?
The bulb will blow.
That's right. You remember we studied the flow of the water? So this bulb is like a little ball without a brick. And this is a very small ball, 0.015, thousandths of an amp, right? So this ball will just blow away if we don't put a resistance. So what we need to do now is to put how much resistance? 600, right? So we need to put our resistance which is equivalent to 600 ohms, right? I mean, you know, so yeah, I mean, we can put, yeah, I mean, it doesn't matter if exactly it has to be 600, but it has to be very close to 600, right? Okay? So we know how LEDs works. we know how batteries works now, right? Now we need to look at how do we identify whether resistance is 600 or what is the value of the resistance, right? So I'll tell you how to do that, right? So have you connected it up?
You search up on the internet the code.
Correct. So do you wanna go on the internet and look for resistant script codes or something like that?
Exactly, that's what they need to do.
What's it called? What?
Script code.
Wait, strip code or what?
Since what video is it? And then we check the image. Okay. Feels good. Connect it up. That's very confusing. For beginner, like a beginner, I just started using my first lesson.
So that's why you need to come early, so Sarita, we were a little bit late as well, so we just allow this, but you should come early, so you, otherwise then you're gonna ask what's the password to change the internet as well.
It sets off.
I will do it.
Resistance color.
Papa mobile not here.
I don't have it, I'm sorry, just a second.
So if you go up, right? So up.
Shan go up, that's the thing.
Oh, that's Hamza putting that on.
Excellent.
Oh, it doesn't talk. So don't worry. Let's do this one, right? So okay, so put. I think that's the green one. So put.
Okay, it tells you on the thing right there.
So what's the website called?
It's called digikey.com. I'm looking.
DG King, right?
DigiKeys.
DG Key, okay.
I'm looking. Wait,
Where's the brown one?
what do we do?
Old one. Okay.
What do we do now?
So 560, right? So you guys see this one?
Give them and find the resistance, how much is this one? They find the 600 one.
Wait,
Huh?
what's this?
I'll tell you this. Yes, this is. So this one. So you know, okay, the way resistors look, right?
You can go find it this side. Oh, that's okay.
Open board.
Yes, I found it. Someone keeps using.
What's it under there?
Video. No, I don't want to buy it.
अगर तो इसको ऑन करना है तो
Do I want to go on this website, Sarah? I don't want to. Someone help me.
I'll cost this.
How's this work? Hamza, this is so confusing. This is very confusing.
So this is how that's how the resistors look, right?
No, good.
So if you want to check, if you want to check the how much resistance a resistor has, right?
Seconds.
You have to put
I'm okay now.
Okay, so this one, okay,
Yeah.
this one has got a green strip and a blue strip, right? So put a green strip here. And then the blue strip, and that's the brown strip. That's it, yeah. So this is 560 ohms, right? Okay, so the one that starts with the green one, that's the 560 ohm resistor, right? So we're going to be using this resistor today for our circuit, okay? Okay, so now I need to tell you guys another important thing, right? Let me do that first.
Uncle, we could use the laptop. We could use the laptop. It's
Which
much
one?
easier.
Yeah, so we will, when we program, then we use the laptop. Yeah, okay? So I need to tell you guys another important thing. The bread, how to, so this thing here, right? You guys understand now how do we play with the batteries, with the resistors and the LEDs, right? So now we just need to build a circuit. So this diagram here, how do we build that on this thing? I mean, we can connect it like, with tape as well, but I mean, this board is very useful when you have to build some complex circuits, right? So I'll tell you how this board works. And we'll be using this board for our experiment today, right?
What is called breadboard?
Breadboard, yeah, breadboard. Okay, so this board has, and that's the inner circuitry of the board, right? This has got two strips here, two here, and then it has got a gap in between. That's a gap, right? And then you have got these lines here. This is how the board is connected, right? So this red line is all connected, right? This blue line is all connected, right? These ones here, they are not connected this horizontally, they are connected vertically. And then you can see this little gap in the middle, right? This is a gap, and then it breaks the connection, and then the bottom one are also connected vertically, right? And this red one is the plus sign, and this one is the minus sign. So you remember plus and minus?
Yep.
Right? These are plus and minuses, and then these ones are to connect things together. So normally, what you do is that when you build a connection, you connect a wire from here, right, to something here, right? And then you connect an LED. So LED from here, not to here. Don't do that, right? Because that's going to be the same circuit. So you don't connect here. You normally connect the LED to here. Okay. Then you connect this with this. You can connect from here a resistor, connect it here, connect from this one, this thing, back to minus. So how will the current flow? Current will flow from here to here, go into the LED, come here, go to the resistor, come here and go to negative. So the current flows from positive to negative, right? Yep.
So what it's basically doing, it's creating like your own special wire, so you don't have to just get your own metal wire and then play around with it and then...
Correct. So it just has a connectivity already done.
Yeah.
So you just connect the wires. You have to still connect these 2 points with wires, but the internal connections are already done, right?
So the whole idea is like if you have to get an LED and you need to connect with the resistance, it's gonna be like problem every time you how to twist it, and once you twist it,
Correct.
you can't reuse it.
Right.
This one is make it quick, you just plug it in there and
Exactly.
it's already there.
Exactly, yeah. It just makes it easier, right? Okay, and then, so what's missing? We have LED, we have got resistance. What's missing?
Coding
Huh?
and the power.
The power is missing, right? So this thing doesn't have any power, right? So what we need to do is take the battery, the 9-volt battery. This is plus, that's minus. So where will the plus go from here? To the plus here, exactly. This plus will go here, and this minus will go to the minus here. And that's it. This will turn the LED on.
As long as we have proper resistance there.
We have to have, so these guys know, right? Why do we need the proper resistance, right? Otherwise the LED will blow, right?
Yeah.
Okay, let's do this now. First let's do a little test. So we get this battery, right? Okay. Do we have some pen or paper?
Yeah, many. What do you need? Okay.
I need one mathematician who can do some equation for us, right? Okay, so the way we use this, plug the powers in. Exactly. So the black thing is normally the ground, right? Oh, sorry. You know what the ground is?
The ground is negative.
Negative is always ground, right? Okay. Because ground is always lower, right? So things come from the top to the ground, right? So ground is negative.
This is basically jumping. This is basically jumping the car.
Jumping a car.
Yes. You know how you do when the battery's dead?
Oh, yes.
Yeah, see the black and the red one.
That's exactly right. Yes, exactly. Exactly right. Okay. Let's put that in here. Okay, so I think in the future we'll talk more about this, and you'll learn this as we learn more. So now we want to use this battery, right? And where is the other box? Oh, here we are. That's one. This one, yeah. So we'll probably use 2 batteries for now, right? Okay. So first of all, we will check. I mean, it says 9 here, but we have. So you see, plus. Yeah, it's a very small value, so it keeps on changing, right? Because every human has also some electric charge, right? So when I'm touching things, I have a charge. So this is a very sensitive device, right? So it's getting my electricity charge and showing the numbers. Okay, or the environment, there are lots of electric wires here, right? So they also get some charge. Okay, so the positive, so this is the positive, right? The positive goes to positive and negative goes to negative. Let's check what is the voltage on this one. What's the voltage?
9.35.
So can you note down the 9.35? So you see,
So they lie to us. They say 9-volt battery.
yeah, it's a little bit higher than that. Yeah, 0.0. Yeah.
So it doesn't hurt.
So let's check the voltage for this one.
The other way, yeah.
7.67.
7.67.
So is mine either weak or it's just...
Yeah, I used these batteries before for.
So do you lose the voltage after you...
They
Okay. That's a new thing.
I think this is not any good for us. Let's check the voltage for this one. So you see, before you can't just believe the number here, right? So you have to test how much the voltage is, right? So let's check the voltage for this one.
Plus.
That's good enough. 9.13.
So next time we can check the battery health, Shyam.
So this is 9.13.
So this way we can also check how much current they hold by some way or no?
So
Say the health of a battery.
the current is the flow, right? So at the moment it's an infinite current from here to here, but we'll stop the current flow.
No, I'm
we
just
put
saying if
some
I want to
resistance.
check the health of the battery, how much battery life left, we can't.
Oh no, we can't check that.
Okay, no
It
worries.
depends on the usage and everything. Yeah.
Okay, cool.
Yeah.
No worries. Carry on.
Okay. So that's it. So we have checked the voltage, right? So they both are pretty much 9.20. You can average that out, right? So they both are 9.20. So let's pack this away. So you guys know what this is used for, right? So to measure.
It's a multimeter. You can measure many things with it.
Exactly.
And we have one
very
in there,
useful
right?
device, yeah. Let me pack this thing. These things are very sensitive, so you have to be very careful that you make sure you pack things away properly, otherwise they'll not give you the right values, right? Okay, so we have got 2 good batteries, right? So we have got this thing sorted out, okay? Now, what we need to do, what we need to do, okay. So now we need some jumper wires, right? So these things are called jumper wires, right?
These were jump, right?
They are jumping wires. So okay, so now I mean I don't have anything to connect these together, but yeah, I mean let's roll that out. So okay, so we have got this sorted out. Now we need an LED and a resistor, right? Let's get an LED.
Just the blue one.
Blue one? Okay, let's get the blue one.
Yeah, blue.
Okay, blue LED, and we need the 560 resistor, right?
That has
So that's the 560 resistor. Okay, good. So, okay, tell me guys, how should I connect this? Is this the right way to connect the LED?
no. You have to put it in the plus and minus, negative and positive.
No.
Right? No, you have to put it horizontally.
Horizontally. You see, I told you guys, that's the way it's get connected, right? So I can't connect it on the same line, right? Okay? So this is the right way. And we have to remember the positive and the negative, right? So on my left hand side, we have positive.
On the right hand side, we have
Okay, and now we need a jumper wire. So which was the positive end?
the left side.
The left side. And can I plug it here?
No, because there's a break in
Why not here?
There's a gap.
There's a gap, right? There's a gap, so I can't do it here, right? So I have to do it here. And this goes to positive, right? And now I need, so now the other end of the LED needs to go to a resistor, right? If I plug it to negative, it will blow away. So now we need a resistor, so we twist the resistor a little bit. So resistor goes exactly the same way as the LED, right? But the resistor has to connect to the negative of the LED, so it has to be in the same row. So you see here, it has to be in the same row to be connected, right? So we have to connect it here. You have to be a bit careful how you connect this, right? And now that's done, so we need this negative point to go to the negative circuit, right? Does that make sense?
Yeah.
Can you check if it's correct? Is it all connected? So here we have to make sure that it's all connected from positive to the negative. Can you guys verify?
Yeah, it looks right.
Do you want to connect? Do you guys want to connect this one? Yeah.
Just copy it.
No, don't copy it. Connect it in a different way.
Alright.
So give one breadboard there and
Should I
one
take
to
it
them.
Should I take it out?
Yeah, take it out. Yeah. So first you can check how it's connected, and then take it out and connect it yourself.
Bread.
Stop taking I don't understand how it's made of dough.
Hmm?
Because bread is made of dough.
Breadsticks.
It still has a... Thank you.
So right is negative, left is positive.
Don't touch it. One from that. One from that.
Oh, maybe we could pass that one to someone here.
Yeah. Okay.
Ian, can you join my brother this? Brother, let him because he won't be able.
Okay.
Just
Okay.
to join what
Shall
he's
we-
doing. And what's
I
your
want
name,
Ian and-
Ammar? Can you explain to Ian what's happening? So it will help you to learn.
Do you want to try
I've already done
yourself?
Okay. Positive.
Let them do this, okay. Two groups. You join them.
This is.
And one should be commentary, telling what's happening.
Okay, so right now Shayan is
अब
connecting.
ये मेरी philosophy है.
It was...
Wait, I think I did something.
This is already red. Now it's
और जो बाहर बैठे हैं,
positive.
Okay, yeah, she'll do it and then you do it.
What we're trying to do, Mustafa, we're trying to put it on the same row as this resistor and the LED. Okay?
If
So you see where you put that little wire?
this part...
So you try to make this go the same row as the wire. and connect it to the positive.
Good job, very good.
So now we're giving
I
power
don't
to the
think
LED.
it's
Okay, pass.
Okay, no, I want to test it.
पहले वो भाई check करेगा whether it's right or not, and then you can test it.
Oh,
चलो check करो whether it's right or not.
Well, I just left it. It's hooked. So
Wow, it's working. It's good.
Very good.
So this is a proof that this is a science where you don't need to ask anybody, you can ask yourself. If you see the light come,
Hey, I wanted to test it.
Why?
Here's your ring. Here's this one. Get over here. Okay.
Now,
We need to code it to let it blink.
different color, where's the box?
Green.
Yeah, we want to try green.
Green and red and yellow.
You see?
Oh, I want to try
Put
to
green. So are we allowed to put multiple LEDs on the same row and it'll still work?
no, you need to have a different resistance, right?
Yeah, that's right.
Because it requires more.
yeah.
So, yeah.
That's what these two are trying to
So
do
it
here.
looks like, could you put this in?
Don't put it.
Very good, excellent.
Wait, comes up.
So
Oh, I
number
said
one,
it was
on
changing
this side, negative on this side. So longer.
No, it's not.
Yeah, push that in. Middle. Yeah. Oh,
Put it here. And this one, okay, one more.
So all the circuit we're gonna keep it connected,
Yes.
and we're going to next level. What is it?
Coding.
So we're gonna talk to it through computer.
Yes.
I'm gonna talk to
Very
the
good.
computer.
Okay. Okay, guys. Now we are back to the whiteboard.
I hate these chairs. We need a smart chair. They take too much.
I'll change the password. Yep. We'll get on with this one. Equipment, breadboard, LEDs, resistance.
I think you didn't press enter.
No, hold on. Oh, man.
What's wrong? Okay, put.
Why would I have a camera back there?
So, mouse it.
So we can put that.
Okay.
I have a camera back there.
So now we need to learn a little bit more about how robots work. Okay? So keep that aside. All the knowledge is good. Now come back and let's learn about robots. So, so I told you before, robots have three main functions, right? Sensing, action, and emotions, right? So today, we are going to be learning about action. Okay? In the future, we learn about sensing and emotions, right? So today is just about action. So first, we have to give birth to a robot, right? So first, the robot has to be born, and then it can perform action, right? So how do you give birth to a robot? It's called setup, right? What's setup? Setup is setting up a robot, right? When a robot is live, right? And then, so when a human being, when we are born, right? Then we keep on going until we are dead, right? So it's, I mean, every day we wake up, we do work, we go to sleep, then again we wake up. So it's a repetitive thing that we have to do for all our life, right? That's called a loop. Loop is going around in circles. Keep going, right? So two things, right? We get set up, we are born, and then we keep going in loop, right? Okay? So two things, right? Keep that in mind. So action. To do an action, we have to first what?
Set up.
Set up, right? We have to first set up, and then we just keep going. Okay? This is what we're gonna learn today. And now, so what's the most important part in your life to perform an action?
Having energy.
Yes, that's important, yeah. But energy is the battery. The battery, the 9 volts was your energy, right? What else do you need? Yeah, so once you're born,
The brain, like
the brain,
The
right?
thought.
So we need a brain, right? in robots, the brain is called microcontroller or microprocessor, right? We covered that a little bit last time, right? Okay. So what does that look like? It looks like, I mean, you've got one, right? So that's a bigger brain. That's a bigger brain, right? And that's a smaller brain. Okay, so there are two types of brains. They are both microcontrollers, right? So we need these brains, right, to function. Okay, right? So now what are we going to do? So action. Okay. Do you know how to program, right? You know basics of programming, right? Do you know programming as well? Yeah? Okay. So do you know what the variable is?
Yeah, variable is something that holds a specific value.
Very good. Yeah? Is that clear?
Yes.
So that's good. So you guys know a little bit of programming, right? Which is very good. Okay, so what are we going to do? We build this circuit. We had a battery. 9 volt plus minus. This went to an LED. For the resistor and the resistor, we went back to negative, right? This was 560 ohms. This was 0.015 milliamp. So this was our circuit, right? Right? This is what we did. Yeah.
It was amps.
Sorry?
It was, wasn't it amps?
Milliamp, right?
Oh yeah, 0.015 amps.
Oh, sorry. Oh, sorry.
Yeah, it was
Yes.
yeah.
Yeah.
Oh, that's good. They're
You're
awake.
listening, right?
Do more of these things. I want to know they're awake.
So yes, you're right. Thank you. So that's amps, right? Okay, 15 milliamps and amps, right? So this was our circuit, right? This is what we just built. Okay. Now so the thing that controls the circuit. So you know when you were connecting the battery, the LED was turning on, and when you disconnected the battery, it will turn off, right? So the thing that controls the circuit is the energy. We talked about the energy, right? The battery, right? That controls the way things work. So now we will control the battery, okay? So now what we will do, okay, I think that's about right. So what we will do, we will build a computer program that sets up the robot. So this is the robot, right? The brain is the robot, right? So we'll set up this, right? And then we will put it into a loop, right? And we'll connect this brain with the computer so that we can program the brain, right? And then this brain will control the flow of electricity, right? When should I send the electricity, when should I take it back, right? So pretty much we'll do a very simple one today. So it will be blinking of LEDs, right? So LED will turn on and turn off, okay? So now that so this is what we are going to be doing next. And there are a few more things that are important. So on this microcontroller, you have got, so you got a few, I'll pass it on, right? So there are there are few things that are starting with a D, and there's a GRD, and there's 5 volt, right? So these are the three things we'll be using, right? So 5 volt is the battery, is the supply of current, right? Ground is negative, we started negative. So this is negative, that's positive, and D is the digital input. So D is where we program when do we have to send an input and when we don't have to send the input, right? So
basically, positive and negative powers it up, and D is a communication line between computer and the microcontroller, right?
So D is the thing that controls the flow of current.
Oh, right.
So that's a variable, right? That will control when to send the power and when to stop the power. Okay, so I'll pass it on. Look for D, GRD, as well as 5 volt. Can you see that?
Do we connect the battery to that, or does it have?
Well, we'll get the power from the computer, from the
Oh,
network. Yeah. But you can connect. Yes, you can connect the battery. Yes. Yeah.
Could you guide me to where it is? I can't. So G.
This is 5 volt, and these are all the D inputs: D1, D2, D3, D4, D12, right?
Okay.
Yeah, so basically
Okay.
it's the D inputs.
So it should be same here as well.
That's the D.
That's the D inputs.
Ground. There's a ground over there. There's a big ground here, and then the 5 volt.
Right. Exactly. Okay. So yeah, do you want to pass it on?
Hamza, can you explain to brother Mustafa?
Okay.
Mustafa?
Okay, so here you see there is the. You guys take this.
So look for G and D, not GRD. That's it.
Okay, so if you see here, let's see ground. Okay, G and D. Ground. That's the. That was a negative.
It looks like a lab now.
That was a negative.
I like mess, organized
Ground
mess.
is the negative. Okay, and then okay, there's a 5 volt. That's the positive. That's what gives power to the LED. Okay, do you get it?
And it's a complete workshop. You get the whole thing from scratch
Okay, and
to.
then all of this.
So we are doing a crash course on the robotics.
All of those are what you call inputs. They are what control how much electricity goes through to the
अब इसमें ये कि one,
and everything.
if he doesn't understand, but he learned it.
They can educate them. Yes. There you go.
Because if somebody can demonstrate what they learned, it means they have it.
Yeah.
They're not using any notes.
Explain, come.
They're not using any notes or anything.
No, this one's different.
Yeah. But honestly,
No, we will have to come back and continue.
okay, so
We're gonna spend a day on
this is
this.
more clear than
I
that.
know all this.
But okay, you see these? You see these numbers down here? They are the digital inputs. Input is how much electricity goes through to the LED or whatever it is, okay? And then there's the ground. Remember negative, positive? Ground is negative. And then look here, there's a 5V. Can you see 5V? Yeah? That's right. You know how you turn on a switch? And then this light? That it's straight. Yeah, it's straight. Okay, it's straight.
The one thing I want to share what his Hamza is saying is very nice. You got to now VAR system. The formula for the volt I into R. Now you remember you have a creative imagination exercise. Now whenever you see a light, your brain should go, what's happening there? What this switch does, what he gave me an idea. So look at all the lights working on those three variables. Your fan, how you turn it, increase the speed, your air con, they're all using, whatever you see electronics, they're using the same basic thing. All you need to talk about it and say how this is a V, I, R, where is the V, where's the I, where's the R. Make sense? Back to you.
Okay, ready? Now we are going to be starting some So this is what we are going to be building, right? Okay. So first we'll create a circuit. So the circuit, previously we had a battery here, right? Now the positive end of the battery will go to D10. So on your microcontrollers, you have to connect this to D10, right? And the negative end will go to the ground of the microcontroller, right? And using the computer, you will program the microcontroller when to send the electricity and when to stop it, right? Okay? And the output will be that the LED will blink and then it will stop and then again it will blink and again it will stop and it will go in what?
A cycle.
In a loop, right? So this will go in a loop. It'll keep on going. Okay, and we can put some delays here, right? Okay, yeah?
Yeah.
All ready?
But as a dumb person, I asked, but these kind of things you can buy in from the shop and then they do this thing automatically. So what's the purpose of building this one? Any idea? What's the difference? You know, you go to shop.
So you learn how to make this and you can use this in some other project.
Excellent. This is the first thing you're gonna be learning about it. The second thing is, here you control the timing, and we didn't have, we also learned this, giving me a lot of burning idea. You can have different color LEDs. Same LED can
We can make
be different, and you can make something for your house like that. Oops. Anyway.
Sorry.
Okay.
Okay, ready? So let's build the circuit first, and then we'll program it, right? So we don't need 3 of them. We will probably use 2 of them, right? Okay, maybe this one. Or maybe let's use. So I'll put that one back.
So, put this back there.
No, yeah, we'll use that one. So put Hamza, put those cables on over there, on top of that one box. And the LED is back. So we'll just use 2 circuits, right? Okay.
Yeah. Jan. Misbah.
So we have got 2 different microcontrollers, right? So they both work differently, which is good, right? We will learn both of them. So with that one, you can connect the wires in the controller, right? For this one, you have to connect it to a breadboard and then get the wires from it, okay? So now we take one of this, yeah? Okay, so what are we going to do now? So guys, what we decided, so where will the positive go?
So, positive will go in the
5 volt.
5 volt.
Where is the 5 volt? On which D number?
D10.
D10. Okay, so where is D10? So can you see D10?
That's D10 is
Yeah, so it will go right next to D10 here. Okay?
So both the legs of the bottom of the D10 and this wire, because they are linked from the breadboard, so they are connected now.
Right, okay. And this one, where is this one going?
to the G and D.
G and D. Where is G and D? Can you see? Do you want to come close as well?
Just make a circle behind brother Fawad. Just Hamza, be on together, beta.
Right in line somewhere here. Okay? That's it.
Stop, Hamza. We'll do later. It's already there.
You guys are done?
No, we're still
Huh?
we're still listening.
Yeah, so just connect it.
Yeah, okay.
Just connect it.
So they're copying you, right?
Yeah.
Okay.
So we are both making the same thing, right? G and D and D10. Okay?
Don't Hamza don't forward, just
You can see everything he's doing, Baba, right there.
yeah, I know.
Let's just confirm.
We just so first we're setting it up is getting born.
Yeah, I've set it up.
Set it up, all good? Okay.
Do you think first?
You guys wanna, okay, so let's do this. Right, very good, okay.
Yeah, I'll tell you how to
So you guys saw this, right? So what was set up?
Setup. Which makes it goes again and again. In a cycle.
Perfect. Okay, so there are only two things, right? It's not complicated. So first, let me open some example. I don't remember the syntax myself.
You go to File, you go Examples, and Basics. And then you go Blink.
Use some other example.
That's a more difficult
Yeah,
one.
that's fine. Yeah. So first we will create.
Should we?
Uncle, there's an easier one if you
That's
want.
fine. That's fine. Yeah, that's fine. So first you guys learn about. Oh. How do I go back? Copy and.
This is the most exciting part. If you miss this, this is the now we're getting to the point where we feel we are
How do we
controlling the whole show.
Yeah, okay.
Computer geniuses.
Okay, so this is, we have created a variable and let's call that, so what was the pin number? Pin D10,
10.
right?
And
And this has to be 10, right? So this is the number 10 pin on the circuit, okay?
So what is this we're doing? Is just the
coding.
so we just created a variable which is integer
Right,
and we set the value already to 10.
because the pin number was 10, right? So can I
That's
have a
fine.
quick look?
But
Was
what's
it
the
in
10 equal to?
Yeah, it's 10.
Yeah, I'll put it to
10, very good. And the G to give birth to that pin, right? Which
What's the 10 value stands for?
So 10 is the number of the pin. So if you look at the board,
No, the D10. So it's just a pin itself.
it's just the pin. The pin number name is 10. Yeah.
Okay, no worries. So whatever
Yeah.
the communicator we do, that's fine.
So okay,
matter what pin you put it in?
it doesn't matter.
No.
Yeah, it
Unless
doesn't
it's
matter.
in
Yeah.
the code.
So now we have to activate the pin, right? So this is the activation of the pin, and I'll tell you.
Ian, come here.
Oh, man. I don't use Windows laptop, so I'm struggling a little bit.
Really?
How
Use
do you
Mac.
copy paste?
Control C.
To control me.
Hang on, sorry. How do we undo? Control Z.
Control Z.
Yeah. Okay.
So for Mac it'll be Command. For Windows we just use Control.
Yeah.
Control
exactly,
C.
Control C
And control me.
and Control V. Okay, yeah. Okay, so pin mode. So these pins, right? 0 to 12. These can be input pins or output pins, right? So input means they are listening, they are sensing. So when we create the sensors, then those pins will become input pin and they will sense what's happening. So if it's an input pin listening to temperature, so the pin will sense what the temperature is, right? But right now we're using that as an output pin. So output is always electricity, right? So 5 volts, right?
And
It will output 5 volts, right?
it has a symbol next to it as well.
Hmm?
And doesn't it have a symbol to identify output?
Correct, yeah. So there are some pins that are only output and some pins that are input and some pins that are digital input and some pins that are analog. So we cover all of that, right? So we cover all of those details. So is 10 the output pin, right?
Near 10.
That's output.
Yeah, I think it should be good, yeah. Okay. I think every pin can be an output pin, but their input pins are restricted, yeah. Okay, so this we have to program, what was the pin number?
10. So
Pin D10, right? So the
Yeah.
variable name, right? So pin D10, we have programmed that pin now as an output pin. Okay? So now what we have to do, let me check the syntax again. How we set, oh yeah, here.
Ayan, if you want to...
Take the note. Well, we can record as well, but it's okay. That doesn't, that flickers. It's an old TV, it flickers, so I can't get the...
Okay, so D is the digital pin, right? So that's why we use a method called, oh, you can watch it there as well, right? So, which is the digital write, right? So we are writing, and we are writing through digital pin, that's why it's digital write. And what are we doing? So pin number is pin D10, and we are turning it high. So high means send the current, right? Right? So let's try this one out just quickly.
Save it onto desktop.
Just save it.
Yeah, let's just save it, yeah. Okay, so let's see. So this tick is the compiling of the code.
What's this program called?
Arduino. That comes with the chip, yeah.
Oh, it's come with the chip.
So
how much is the whole kit cost normally if you need?
I got this for free because
$30
my
or
cousin
something,
gave
yeah.
it to me.
Yeah, it's
Okay.
very cheap, yeah.
Okay, cool.
Okay, so
The software is free though.
so now the LED should.
I'm trying to make
So you see the LED turned on, right?
Yeah.
Right? So because why it's turning on? Because we have set it to high, and it will always be turned on, right? It will never turn on because this loop is keep on going, right? Okay. Now let's do some delays. So you remember we need to do some blinking, right? So we'll say, okay, keep it up for 5 seconds, then turn it off for 5 seconds, then turn it on for 5 seconds. So that sort of loop, right? So we say, okay, so this works in milliseconds. So 5,000 seconds delay, and then what it should do after 5 seconds?
turn off.
It should turn high to low, right? So
Yeah.
low, right? Low is like dim. And then it should again wait for some time, which is 5 seconds, and then turn it on. Okay, let's see. whether
So
that
5,000 means 5 seconds.
5 seconds, yeah.
Okay.
Because
It's in
for the
minutes.
computer for second is too big.
1, 2, 3, 4.
So let's see how it works.
1001, 1002, 1003, 1004.
It's gone off. So you see?
Also
It's
see
coming.
the chip as well.
Hmm?
The chip also communicate when it just send a new signal or communicate.
Yeah. So it is coming from the chip, right?
So the program, so see, this is the basis of computer. Now the software talking to a machine to do something, that's robotics.
1, 2, 3.
That's it, guys. We are done for today.
It's good. And you can extend this program with your knowledge. You go to the different website, for example, the ultimate can be like it link with your song. You speak, it plays things. Then we're gonna do sense part.
Excuse me,
Talk to uncle.
Uncle. Is it fine if right now, so we're finished up, that's everything. So it's fine if I just go onto my laptop and use the software?
Yeah,
So-
yeah,
Okay.
yeah,
So
yeah.
I'm just
What are the
Yeah,
things we
yes,
need
please.
as the people who are watching this video?
Right now.
So what are the things they need? They need to have that kit
I use Google Drive, so.
and a breadboard and a LED and some jumper leads and resistance.
So what do you want to say?
We'll list it out, we get
I
it from
have
you
set up, you could
and we
just
put it up there all together. It's gonna be a long 2-hour video. People, let's see if people cope up with that.
Yeah.
Okay.